what we're here to do today is just show you what could happen if you use compost and introduce compost into your growing system. You can reverse some of that damage that happens when you just use traditional chemical farming techniques. I know there's a move towards incorporating more organic matter, but it's still not sufficient really to pull back the normal breakdown or degeneration of soil physical, chemical and biological properties of the soil. So we're trying to reverse that. So if we manage to do that, we can expect to see improvements in soil structure. Now, soil structure is just basically how open is the soil? What's its porosity like? How well does it drain? How much air is in it? All of those things are very important for the health of a crop, because you may not understand this, but roots actually need to breathe, so they need oxygen. So if you have a really hard packed soil, then you're not going to get enough oxygen for the roots to breathe, and therefore it's going to have impacts all the way down the line. So when you add organic matter in, you can expect there to be improvements in soil structure, better drainage, better airfill porosity, root elongation. So what happens if a soil is not well structured? The growth of roots through the soil is inhibited, so the length of a root becomes restricted. And what you may not understand is that most of the nutrients are taken up from the very beginning of the roots, not the full length of the roots, just the very beginning of it. And so a root must continually grow to have optimum nutrition. So anything that inhibits root development or elongation is going to have impacts on plant nutrition. The second thing, increased soil water holding capacity. So you can expect there to be less drainage losses through your system. You'll be able to turn your irrigation system off a little bit earlier and save water, and you'll save fertiliser as well, because the leaching of fertiliser is as a result of irrigation water running through the profile. You can expect increases in cation exchange capacity. Now that's just simply the ability of a soil to retain nutrients from your fertiliser program. So that will reduce nutrient leaching and groundwater contamination. So groundwater contamination is where the fertiliser washes past the root system below it, so it's no longer accessible to the crop. And once it gets down there, it's now in the groundwater. And there are issues with nutrients moving off-site in some locations. So the final thing I've got here is increased soil biological activity. And this is an area that I think is really the key to all the use of compost. This is the thing that makes the difference about using compost over some other organic sources, say, for example, poultry manure. With a good compost, you can expect there to be disease suppression, improved root development, improved nutrient uptake. Now, this is an area which is it's just sort of evolving. There's a lot of interest in this area, and this is where I think we're going to focus a little bit in this trial more, because the health of the soil, the biology in the soil is absolutely key to having a healthy crop and having a crop that's full of nutrients for people to eat. So our basic trial design was that we had a treatment which is inorganic fertiliser. So this is like your current grower practice based on nitrophosphate and other chemical fertilisers. Okay, then we had a treatment which was 10 tonne per hectare of just straight compost. We didn't have any base chemical fertiliser in this treatment, and the reason why we didn't do that is because 10 tonne of compost, even at 1% nitrogen in that compost, is a hell of a lot of nitrogen. It's actually more than what the crop, in theory, requires in that cycle. But the thing about compost is that the nutrients aren't just readily available. If you think about traditional chemical fertilisers, you will find that they are highly soluble. And they have to be soluble because plants absorb nutrients from the soil solution. They must be dissolved first in the soil solution before roots can take them up. And it's been said that plants are actually soup eaters for that reason. They don't eat solids, they don't eat the solid fertiliser that goes out, but it has to be dissolved first. And so the thing about compost is it's an organic product. It's not soluble, you can't dissolve it in a bucket of water. It slowly releases the nutrients over time. And so you might not expect to get a big flush of nutrients when you first put it out. But you can expect it to be releasing nutrients over maybe 5 years. Okay, so you've got to think of it in those terms. Think about the inorganic fertiliser as being like sugar. You put sugar on, you get a big flush of, when you eat the sugar, you get a big burst of energy, but then it goes. It's gone. It doesn't sustain you. Eat Weet-Bix, it'll stay with you until lunchtime. It's a slow release form of nutrients and energy. So we had 10 tonne per hectare rate was intended to show a rate that was roughly the same price as the poultry manure at 25 tonnes. So we're thinking, well, you guys don't want to spend any more money than you're currently doing, so let's have a look at a rate which is possibly commercially viable. You just simply replace one product with another. So we went to the 10. We went to the 40, which seems like a ridiculous rate, but that was there because at 40 tonnes per hectare, you expect soil physical changes to occur. All right, so that's a very high rate. Then we came up with this concept of NextGen Compost. Now, what's behind that is that it's well known in the nursery industry when you have potting mixes, or people who make potting mixes, that because of the increased biological activity in the organic matter, that the bugs that are in there breaking down the compost actually need nutrients. So what they do, when you put it in the soil, they compete for the fertiliser that you've got in there with the plant, with the crop. So what you've got to think about is how do we stop that from happening? It's called nitrogen drawdown. That's the main thing, or nitrogen immobilisation. And the thing about it is, it hasn't really been thought of much in compost research. I had a look at the review of all the compost trials that have been done around Australia for quite a while, and I don't think anybody's bothered to take account of nitrogen drawdown. They haven't supplied additional nitrogen for that reason. And it's not just nitrogen, it's phosphorus and trace elements, everything in there, because the bugs are really small plants, microscopically small plants. And so you must think about feeding those bugs in the soil when you put this product out. Okay, so what we did is we looked at applying a slow release form of fertiliser, of nitrogen fertiliser, to the compost before it went out. We put on enough to balance off what I expected the nitrogen drawdown to be on that product. So our NextGen compost has been tricked up with a bit of slow release fertiliser, which releases over about 3 months, this product. It's not a controlled release fertiliser, it's a slow release fertiliser. We put on enough to do that. We've also adjusted the ratios of N, P and K, or nitrogen, phosphorus and potassium. So instead of just chucking something out there which has whatever the ratios are, like poultry manure or just straight compost, where the nutrients aren't properly balanced for the crop, we've changed the ratios of those nutrients in the compost. And the idea is we're trying to provide a compost which is essentially a well-balanced nutrient source. So it's gone to that next step. We've put that out at 10 tonnes so that we can compare with the 10 tonnes there. We've got a 20 tonne. We didn't bother going to 40 because that would just be silly. The rates would be just far too high. So we've got that treatment there. And then finally we've got a poultry manure treatment because we see that as being probably the go-to organic matter that you might put on. Simply because it's cheap, it's accessible, and people have used it for a long time. We all know that it works. You can actually get some good results with poultry manure. But we put it on at a fairly high rate, but we know this is a rate that people have actually used it at. Okay? So there are our 6 treatments. So I'll just give you a quick rundown of what the highlights of the results have been to date. So I'm going to start with the inorganic fertiliser. So that's our sugar. We get growth and fruit production has been good, as you might expect. The actual crop looks good. However, we've actually been measuring soil solution using vacuum extraction tubes, which are set about 30 centimetres down. So it's quite deep. At that level, we're measuring really high soil salinity levels, levels that will actually impede the growth of a crop. Now, it's possible that this happens all the time, but nobody takes any notice of it because the tops look good. But in fact, at depth, there's too much salt. And that's going to have an impact on water uptake, particularly if you allow the crop to dry down, because as the soil dries down, the soil solution volume changes, it gets less. And the EC will just go through the roof. It'll just increase, simply because there's less water, the same amount of salt dissolved in it, it'll go right through the roof. So if you've got high conductivity in the soil, it's going to magnify the effects of poor irrigation practices. So if you allow the soil to dry down at all, it's going to just give you a real salt effect. High potential for nutrient loss. So we measured very high levels of nitrate and other nutrients down at 30 centimetres, just ridiculous levels. And again, this may be just normal, but it was quite shocking to see the levels. And so what that means is that's already down pretty well below the root system of most crops. So that's essentially now down into groundwater. Now, for the poultry manure treatment, we found that growth and fruit production were reduced. So actually using poultry manure at that rate set the crop back, right? So the plants were smaller, slower to take off, they're more disuniformity, so more irregular in the way they were growing over time. And you could see that they were really struggling. Highest transplant losses, so we were losing more plants in those treatments, so just simply transplant losses. They had the highest salinity, and I'll show you some of these numbers in a minute. So you'll be surprised how high they get. Highest salinity, highest potential for nutrient losses. What I mean is that the nitrate levels and other nutrients in the soil solution were just really just silly. I mean, if you were to sell this product as a fertiliser and put on the shelf in Bunnings, just this liquid soil solution, it would actually be more concentrated than most of the products you can buy in there already. So it was actually a liquid fertiliser, a concentrate. You'd have to dilute it. In the poultry manure, there were high levels of some heavy metals, and that actually then flowed on to inside the plant as well. Okay, now getting to the compost treatments. The straight compost treatment applied actually reduced growth rate and it slowed and delayed fruit production. In the end, we actually had to put a side dressing of nitrogen on because they were delayed. Nitrogen drawdown was the main reason for that. You could see they were displaying symptoms of nitrogen deficiency. And so, you know, I had expected this to happen, so it was no shock to see it happen. And farmers have known for a long time that you shouldn't incorporate stubble, for example, into soil because of this nitrogen drawdown effect. No salinity and reduced risk of nutrient loss. So what I'm saying there is that the conductivity of the soil solution was acceptable and the nutrient levels in the soil solution were acceptable. Much, much lower than in the other treatments. The main finding we had, though, is the root system were just so much healthier. Really quite impressive looking root systems. Not so much that they were any bigger, it's just the roots themselves were sort of succulent and white. And what was even more exciting was that they were covered with a fine layer of soil. So the roots actually looked like they had a layer, several millimetres deep, of soil attached to them. And they came out looking like dreadlocks, if you can imagine the idea. Whereas if we looked at the chemical treatments, including poultry manure in this, but if you looked at the straight nitrophosphate treatment, good root system, there's no soil attached to those. And so what I believe is happening with that is that in the compost treatment, the roots are actually exuding sugars and things which are feeding the biology, and there's actually a community of living organisms around each root feeding off those sugars, and in doing so actually helping the plant to get nutrients, providing hormones and other plant signals to make the plant grow better. So we're going to investigate that further. So we're sending samples off for testing, to have a look at the biology around the chemical treatments, that's the poultry manure as well, and then the compost treatments, and seeing what the differences are in the biology. So we're now onto our NextGen compost, and here we found that just simply the addition of some additional nitrogen to the compost, a slow release form that would feed the bugs in that compost, was enough to stop that setback. And these treatments here were some of the best treatments that we had. So the NextGen compost treatments actually look really good. They haven't required any additional fertiliser, so just a one-off application of compost at the beginning has carried the crop right through, and the most recent leaf analysis testing we've done indicates that they still don't need any additional fertiliser. So it's just a one-off treatment. But the good news about it is some of that product will be there for the next crop, and then the next crop, and the years and years later there will be still ongoing effects of these treatments. So, no salinity and reduced... So in other words, the nutrients that were washing down through the roots, by the root system, the soil solution was not saline, and it didn't contain excessive amounts of nitrogen or other nutrients. So we weren't losing stuff into the groundwater. Healthier roots, again, is similar to what I said before. I'll show you a photo in a minute. No symptoms of any nutrient deficiencies, and there was no requirement for any base fertiliser, any other base fertiliser or side dressing. So that's what we've discovered. All right, so let's quickly go through some of the results. What we did is we did a quick harvest. But we were concerned that this crop's going to get into some very cold weather, and we didn't want to lose the crop and have no results. So we did a preliminary harvest. We went out there and we actually cut plants off at ground level. We weighed the entire top, and then we picked off the fruit and we counted them, and then we picked off, then we looked for flowers, right? So we counted how many flowers were on. So let's just look at the total weight of the tops and fruit. And you can see here our inorganic treatment is the nitrophosphor. The poultry manure is at that end. Our first treatments, 10 and 40. And you can see that there's been a reduction in yield. And the higher the rate, the worse it is. So that just makes sense. It's tying up nitrogen. You go to the NextGen and you can see that the addition of nitrogen to the product has overcome that effect. All right, that's the next one. And then obviously poultry manure has suffered quite badly. So if we look at the fruit that we pulled off, again you can see here that if we use this as our standard, this is the standard practice, you can see the fruit available is not any different to the compost at 10. That's not because the fruit were actually any good, they were just the numbers we were counting, right? And so when a plant is under stress, it'll often go to flower and it'll produce some fruit. It's just like a stress reaction. So you wouldn't say these are harvestable, good-looking fruit. So I'm not making any claims there. I don't think there's any differences there, right? But we get to the NextGen 10 and 20, you can see that there are increases in fruit number per plant. Next one. And if we think about the flowers as being an indication of future production, so the potential to have more fruit, you can see how compost and NextGen, again ignore this one because that's really just a stress reaction. There's a lot of flowers because the plant's going to die. Okay, but our NextGen is performing really well. Okay, so not only did we have bigger plants, we had more fruit, we had more potential in our NextGen. Okay, so here's the soil solution data I was telling you about. And we're looking here at EC, decisiemens per metre. And if you think about it, we've always been taught that if you're above about 3, you're in trouble. All right, so anything above about 3 decisiemens per metre is too salty. So if you look at your inorganic, this is over time, number of different measurements were made over time. You can see that we're up to, approaching 8 at times, up to 4, so well over 3. Our compost treatments have come down into safe levels. And then the poultry manure was just up to, we got up to about 13, I think. 13 decisiemens per metre. Far too salty. Next one. And now I'm just going to show you the results of the nitrogen figures, right? These are the nitrate values. Again, you can see here that the nitrate levels, this is actually nitrogen as nitrate, right? So if you were to actually look at nitrate, it will be even higher. But just out of interest, when you grow in a hydroponic system, if you were to grow tomatoes in a hydroponic system, you would not expect the nitrogen to be any higher than 200 parts per million, right? So that's enough to grow pretty well any hydroponic crop. So there's 200. So what we've got are levels which are up to 800 in your normal fertiliser treatment, and you come across to the poultry manure and they get up to over 1,000 parts per million. So you can see that the levels of nitrogen you're putting on are just ridiculous, right? Not necessary at all. And you can see the compost treatments are all down at a safe level and within a level that will satisfy the crop. Now this was an interesting finding. When we looked at the poultry manure that we put on, did an analysis of it, we found that the copper, manganese and zinc levels were elevated in the compost, in the poultry manure, right? And I'm thinking that's probably as a result of treatments used by the grower to control certain disease organisms, right? So they're commonly used bactericidal materials, so copper, manganese and zinc. So you see them in sprays like mancozeb and copper sprays, you know, you'll be aware of all that. So I'm thinking that the poultry manure is contaminated by these compounds. So if you have a look at here, you can see that they're elevated even in the chemical treatment for some reason, but certainly in the poultry manure treatment, you can see. Now, this line here represents a level above which, if you get those sorts of levels, you're going to have a setback in the crop. So manganese was actually toxic in that treatment. All right, so I was telling you about the roots. I hope you can see this, but nitrophosca on this side, more like a broom. You can see it's sort of woody looking root system. Those ones are actually much thicker looking. It's because they're coated with soil. And the soil is sort of adhering to the root system, very intimate contact between the root and the soil. That's something we're going to explore in the future. Here's a quick summary of the biological testing that we did. Now this is on soil that had a number of compost trials run over it over a number of years. I think it goes back about 8 or 9 years. Just odd trials here and there. We knew that soil had been treated with compost in the past and this soil had never received compost. So on the left hand side we've got what's the conventional. So this is untreated soil, it's out here. No difference other than the fact that they're not physically different or chemically different, but they have been treated differently in the past. So looking at the conventional, so this is no compost. You look at the speed dials, they're all in the red, okay? We've got nutrient solubilization rate, disease resistance, nutritional accessibility. These are things that are these roles of making nutrients soluble for plants or resisting disease or making nutrients more accessible are all roles played by soil biology and they all help the crop. They're all in the red. Go to the compost, you can see the needle's gone right to it's going to the right, okay? So anything in the yellow and the green area is good. So there are obvious differences in the biological health of the soil. Next one. Just looking at this lot here, this is nutrient cycling rate, drought resistance and residue breakdown rate. These are all just indicators of the sorts of biology that are in the soil. So without compost, pretty well in the red, with compost in the green. So this is where you want to be. You want to be on this side. Next one. And this is just a summary graph looking at overall microbial balance in the soil. And so you've got basically a chemical fertiliser treatment at soil where plant crops have been grown using chemical fertilisers and one where compost has been added in the distant past. So that is a long-term residual effect of the compost. And that's it. Thanks for your attention.